Sorry, I accidentally pressed off. That's probably a good thing anyways, because it won't let me make a very long video. So, we're still on part 1 of this. You've got to see the whole thing. So, what can I say about this? Well, if Newton is right, and F here, F equals mass multiplied by acceleration. So mass multiplied by acceleration, well then mass is interchangeable with force. Mass equals force. Mass is a force. So I have a negative mass and a positive mass. This would imply the negative mass and positive mass would imply that the negative mass and positive mass equals the gravitational force. And what I can say about this is that if I have, I'm going to that corner right over there. If I have the negative mass and the positive mass, so the positive mass, remember, represents the weighted ball, and the negative mass represents the hammock, well then I can say, for these two, I can say that this one is pulling in if this weren't here. And if this weren't here, this one would be pushing out. And that's because the positive mass has mass, therefore it is interchangeable with density. That density is collapsing on itself. This one is trying to get rid of the collapse. So it has a release and pressure. Or I'll write this down at the bottom. So negative mass, okay. Negative mass is interchangeable because of this. It is interchangeable with the release and pressure. So that means that the positive mass I have to write everything backwards. The positive mass is related or interchangeable with an increase. Okay. It's interchangeable with the increase in pressure. So they are opposite to each other. So I can state that because of this, if they were secluded, that is the reason why it's pushing out and pushing in. But once you, what happens if I, give me a second. So, about the only way I can actually do this. Hope you're writing all of this down. otherwise it's going to be a lot to remember. This is probably the best way I can prove this. It has not been proven. It is only a theory based on the theory of relativity, which has been proven. So, here, I have, go ahead and use this to start for this one. So, I have positive mass. Okay. Or, I guess over here would be better. So, I have positive mass with its force going inward. This is interchangeable with the increase in pressure. So, based off of that, I can say that negative mass is interchangeable with the decrease in pressure. Well, would be n plus 1 n minus 1. There you go. So, the light covers it so you can't see it, so. So, the negative mass is interchangeable with the increase in pressure. So, if this is without the other, what happens if I add the two? Well then, I would get positive the change or delta or change in, okay, boom, positive mass. Okay, so right here. So the change in positive mass pushing in on itself to positive mass pushing out. So if I add the two, well, now the positive mass has changed from delta of mass to the, so it was before it was pushing in on itself, and now it's pushing out. So that I could state by that, I would also have the delta of negative m negative m pushing out to negative m pushing in. So, look at that. They both changed the opposite way because I added them and they're both opposites. Well, I'll go and bring this up. Now what happens? Well, if the negative mass is pushing in on itself and now the positive mass is pushing out, well then, wouldn't the bend change and increase? Well, no. In fact, it would stay the same. It wouldn't matter because I have infinite lines, which means that the mass is pushing in on itself both ways. So the negative mass is because I have 1, 2, 3, 4, 5, 6. Wait. It's pushing in on itself. So I would have 1, 2, 3, 1, 2, 3, 1, 2, 3. You get my point. Anyway, it would be like a circle, but with infinite lines pressing in, but also on the outside at the same time. So, but wouldn't that just mean that the bottom bends more? No, because this one's pushing in, which means that which means I would have a derivative, a second derivative, a third derivative, pretty much infinite derivatives. Infinite derivatives at the same time. Or it would all be changing so fast that the curve couldn't change in order to make itself proper. Same for the positive. It kind of cancels each other out. So, why am I saying this? You'll have to find out next time.